Hi guys, welcome back to our channel. Today I want to share with you a new concept I just picked up recently, which is called three-way partition. And this new concept can be applied to Leetcode number 75 sort colors. So three-way partition is leveraged to solve problems of sorting or partition, but particularly when there are many duplicate elements within a same array. So we don't want to do partition on those duplicate elements that are exactly served as the partition point, so we can reduce the number of swaps and the future partitions we will do to eventually get the array sorted. So basic concept of three-way partition is that, for example, if you have an array like this, and you have multiple duplicate elements such as many 2s, many 1s, and many 0s, then what you want to do is to choose a partition point. For example, if we have the partition point value of 1, after one partition, it will be like low value to the partition point, partition start, and then to the partition end, and eventually to the high value. So this is called the three-way partition. We chunk this array, partition it to 3 parts: low to p start and all the partition elements, and then the rest to the highest. So that's the basic concept of three-way partition. So in this three-way partition, we want to maintain some index or pointers. One is the low, and the other is the high, and another is the iteration pointer, which we can call it I. Then we'll do some swaps and update the values to get the partition down. So let's take a look at the problem statement. So it says, given an array with n objects colored red, white, or blue, solve them in place. So in place is a keyword, so that objects of the same colors are adjacent, with the colors in the order red, white, and blue, and those we will use the integers 0, 1, and 2 to represent the color red, white, and blue respectively, which is color-coded. So you are not supposed to use a library sort function for this problem. So what is testing you is the ability to do the basic swaps and the concept of partition, and maybe sorting, and how different sorts works. Those are all possible testing points. So the follow-up will be a rather straightforward solution. It's a 2-pass algorithm using counting sort. Absolutely. So you know the boundaries, you know the lowest value, highest value. So you can use linear sort functions such as bucket sort, counting sort, and etc. First, iterate the array counting numbers of 0s, 1s, and 2s. Then override the array with total number of 0s and 1s, and then followed by the 2s. Great! This solution may need extra space, but it's still constant. Instead, you have to do 2 iterations of the same array. So the time complexity is still all of n, but you need to, what you actually need is all of 2n. So could you come up with a 1-pass algorithm using only constant space? So this question is asking you if you can do it better with the solution to iterate to the array only once, that is reducing the time complexity from 2 of n to n. So let's take a look at it and see how we can code it. So there are only 3 values. So our partition it's 1, which is a constant. And then before that, we want to do a quarter case check and return. So if the nums equals now or nums length, it's not bigger than 1, then you should just return it. That's a corner case, and then we'll handle the general case with 3-way partition. So what are the indexes or pointers we want to maintain? The first is the low. We will initiate to 0, and then a high, initiate to nums of length minus 1, which is the last index, and then an I for iteration. Also, we have the partition value. So while I is not bigger than high, we will do get the value of nums I if the nums I is smaller than the partition. Then we will do a swap of nums at value low and the value I. After it, we will increase the low pointer and of course the I pointer, and else if nums I is bigger than the partition, so we will swap the value somewhere here with the high value. So we will do a swap of high and I, and after that the I value was moved from here with the high. The high value was actually placed back to the I pointer, so we don't want to increase the I pointer, but at the same time we want to decrease the high pointer. The rest would be the I value. Nums I is equal to the partition. What we want to do is to increase the I pointer and move to the next number that we want to compare it with. So that's it. Then, because this is a void in place sort color, so eventually after the while loop it will just return. And then don't forget to implement the swap function, which is very basic helper that everybody should know. We have the temp value of nums I, then we assign nums I with nums j, and then we assign nums j with temp. So that's all. And let's deal with our test case. Looks it works. Here we go. Yep, so that's Leetcode number 75 sort colors with solution 3-way partition. Thank you for watching and happy holiday.